Hi, it's Adam from Affinity Energy. We've been working on a couple projects lately for some big energy companies where they want to put in some monitoring systems on what would traditionally be a smaller asset that wouldn't be tied into their corporate infrastructure. And I just wanted to talk through some of the scenarios that we've been working on layers of separation between the site, a potential third-party O&M company, and the corporate entity in order to protect their fleet from hacking or intrusion. Traditionally, the way this would have been done is where we've got a cellular connection and there's a cloud app. So the cloud app is pulling data from the site, and then corporate is reading the data out of the cloud app, and they can allow their third-party O&M providers to get data from the cloud app to see what's going on. The problem with this approach is that to do good analytics on how the site is performing, these cloud apps typically only give you 1 minute at best or 5-minute data. It might even be 15-minute data for the status of the devices that are running at the site. And with 15-minute data, you really can't see, even with 1-minute data, you really can't see how the individual inverters are performing through clouds or changes in voltage or any of the events that happen at the site. You lose a lot of resolution to the data. So corporate is looking for much higher fidelity data. They want 1-second data from the site. And going through a third-party cloud app just doesn't seem to work for these kinds of applications. So I want to talk a little bit about how you might be able to do this with something a little different. First, we were going to put in a router with cellular connection so that corporate could get in through a VPN connection, and then the third parties would come in through the same device with a different set of credentials, but through the same router. And the problem with that architecture was once this corporate connection to the router was established, the third parties were effectively on the corporate network, which was unacceptable to the corporation. So we went and took a step back and said, well, if we put in a second router, and now we have the third parties come into this router through a VPN connection. In here, if these are tied together, we have the same problem. There's still the potential that third parties can go through two routers and get on the corporate network. So that wasn't a sufficient level of separation. So what we decided was we would put in a computer in here with SCADA. And SCADA would have two NICs in it so that router 1 could talk to SCADA through a NIC, and then the corporate network could also talk to SCADA through a NIC. The problem there, of course, is that this computer could be hacked to enable bridging and routing so that it could potentially link those two networks. So now we go to, okay, if we put a firewall between the router and SCADA and put a firewall between SCADA and the corporate network, now we have the ability to manage the connections, the IP addresses that come in here, and the connections and IP addresses that come in here. This approach probably works for most applications, but in some cases, if you wanted to add a further level of security, what you could do instead of having SCADA here is have an OPC server here. And then on this side, we're going to put in firewall here, and I'm going to put in a SCADA computer down here that talks, so router talks to SCADA, SCADA talks to firewall, firewall talks OPC, and now this firewall is configured to only allow OPC traffic. This firewall is configured to only allow Modbus traffic. And now we have a layer in the middle that will only allow one protocol on one side, another protocol on the other side, and now we've got sufficient separation that it's impossible to get from third party into the corporate network to do any damage. So this works, I think, for most customer applications, except that in many times you're also going to want to put a firewall between the router and the SCADA system. So now you have a third party connecting VPN to a router going through a firewall, allowing them to only talk to SCADA. SCADA is only allowed to talk to the OPC server, and the OPC server is only talking the protocol that will allow it to collect data from the devices at this particular site. So you can, as you can see, we can very quickly go from one connection to multiple devices in a network infrastructure. And there's a balance between the level of security and separation that you get with this and the cost of all this infrastructure. Again, if we're talking about a 5 megawatt solar site, it might only have a $50,000 or $60,000 budget for SCADA and controls for the entire site. And this might be $50,000 or $60,000 worth of network infrastructure equipment that would have to sit on top of what was being deployed as the SCADA system for the site. So there's definitely trade-offs between cost and security, but the degrees of separation that can be achieved between the corporate network and third parties to allow them to monitor the site but protect the corporate network are certainly varied, and there's probably more scenarios than this. It's going to depend on what the corporate requirements are for NERC CIP and what the budget and infrastructure will allow for the site.